Olá, sejam todos muito bem-vindos ao Especial Abranet 25 anos. E o convidado da entrevista de agora é mais do que especial, Vint Cerf, considerado um dos pais da internet, criador do www. Vint Cerf, nice to have you here and thank you very, very much for taking the time to talk to Abranet on its 25th anniversary.
So, bom dia, Roberta. Feliz aniversario.
Thank you very much. So the main point here, we are doing a balance evaluation about the past, the present, and the future of internet. So I'd like to start this interview asking you, back then when you created the www, did you realize, did you ever think that the internet will reach the stage we are today? Back then, what did you plan for the internet?
Well, we had Bob Kahn and I did the original design. It was two hands on one pencil way back in 1973. And at the time, we were doing this because the American Defense Department wanted to find a way to use computers for command and control. And we had just, the two of us and many others, had just gotten something called the ARPANET in operation, again, for the Defense Advanced Research Projects Agency. And that project was very successful. It got different kinds of computers connected to each other. We had invented email, networked email by that time. And there was a community of users, which eventually grew to about 50,000 people. That were largely from the engineering and academic community. And the consequence of that is that we had experience with the use of computers this way, this interactive access to time-shared machines, sharing of files, exchanges of emails. We were even experimenting with packet voice and packet video, which goes alongside the command and control theme, which Bob and I started pursuing in 1973 with the Internet Project. The second thing is that we were forced in the circumstances to cope with different kinds of packet switch nets, mobile networks, ground mobile radio-based networks, satellite-based networks, in addition to the original ARPANET, because you had to have computers in the ships at sea and computers in the airplanes and computers in the cars. So by the time we got the internet running in 1983, which is a 10-year development period, we'd already had a substantial amount of experience with the use of this technology. So we had, I don't want to suggest that we imagined every application that we see today, but many of them are quite familiar. And we were already convinced that there was use in the civilian sector in addition to the Defense Department's interest. And this was reflected very quickly by the fact that the National Science Foundation, the Department of Energy, and NASA all decided to build their own backbone internets and connect them. So the research community became an increasingly common component. And then in 1988, I began pushing very hard to find ways to commercialize the internet in order to make it available to the general public. So while it would be wrong to say that at the very beginning we saw what was coming, over a period of some 10 or 20 years, it became increasingly apparent that this was going to be a very big deal, that there was a huge commercial interest in it. And of course, today now there's great national interest in it because there are mixed effects of being online. Some of them are extremely positive and constructive, and some of them not so much. And so now everybody cares about this.
During this series of interview, I talked with the Demi Gates, and he stressed a lot that the infrastructure, the platform of the internet should have its own governance and be a part of what's going upstairs. So don't mix everything could be a real deal, and to the thing that we should keep in mind, look at the internet for, I don't know, the next 25, 50 years?
Well, it's almost impossible, of course, to look that far ahead. I mean, here it is 50 years later, and many things have happened, especially mobile technology, which I need to tell you, though, a story. In 1973, a man named Marty Cooper started working for Motorola on a handheld telephone, mobile telephone, the same year that Bob Kahn and I started working on the internet. In 1983, when the internet was officially turned on, so was Marty Cooper's mobile telephone system. So we were running along in parallel. And then in 2007, Steve Jobs at Apple introduces the iPhone, and suddenly both of these technologies come together and they become mutually self-supporting, because reinforcing, because the mobile phone made the internet more accessible and the internet made the mobile phone more useful. And so the two unexpectedly have come together, and Marty Cooper and I, of course, have become good friends since that time. So I bring all this up just to emphasize that what Demi is saying is that there is a road system, if you want to compare the internet to the roads. And there are some simple rules about using roads to keep people from running into each other. You know, to only drive on one side of the road, have some way of mediating traffic at intersections, you know, create freeways that fly over parts of the territory. And then there's the question of what kinds of vehicles are there on the roads? What can the vehicles carry? What buildings are on the side of the roads? And if you think of the internet as a road system, then you realize that there are a set of issues associated with how the roads get used, which are parallel to how does the internet get used. And so Demi's point is the internet is this global infrastructure. And then there on top of that, literally in the layers of protocol, uses which may in fact need some kind of moderation and regulation. But the confusion factor is that people don't distinguish between the basic road system and all the applications that pile up on top of it. And so Demi's point, which I agree with, is that we should keep those distinct. Now, whether there is a single global internet, you know, body, that's not so clear. There is one which is responsible for some key parts of the internet address allocation and the domain name allocation, and that's the Internet Corporation for Assigned Names and Numbers. And Demi, of course, is very much aware of that. So perhaps that's the only place where we see an existing governance mechanism for these key parts of the internet infrastructure. But the uses on top of that, really, we would like to see more coordinated on an international basis, because we know that in order to deal with the side effects of bad behavior, you may need international cooperation, because a victim could be in one country and the perpetrator could be in another. So the Digital Cooperation Initiative that the Secretary General of the UN has been touting, I think, is a very important signal that the countries need to cooperate with each other, and companies need to cooperate with each other in order to make the internet a safer environment for everyone.
And do you think we are on the path for this? Because if we truly think internet is just 25, 30 years old, so we have the whole mechanisms of lawmaking and international cooperation that's pretty new. I mean, I grew up in a world without internet, and so internet has changed everything. So do we need some time to adjust everything and to better understand?
Well, it's clear that debate is going on right now, and governments, for example, are reacting to the two things about the internet which are true. One of them is that it supports incredibly constructive and productive activity, but it also supports harmful behavior. And so
Sure.
Governments are now struggling because they're saying, well, how do we protect our citizens? So we're seeing some fragmentation because nation states are adopting very different practices from one place to another in order to protect their citizens. Although in some cases, the governments are actually trying to protect the government.
Yeah.
That's a whole other story. So I think if you just think for a moment about the internet itself, just the networking part, you realize that there are literally hundreds of thousands of organizations that are collaborating, in effect, to create the internet. They work collaboratively, each of them supplying a piece of the internet, or some of them supplying the equipment, some of them supplying the software. And so this gigantic collaboration is what produces what we see today, but it's cooperation. It's not centralized. It's not a single authority. And I think what we want is common agreement about the steps that each of the collaborators needs to take in order to, in order to make the internet a safer place for everyone. It's also very important to recognize that there is a shared responsibility for achieving that objective. It's not just the government, it's the private sector, and frankly, it's you and me being careful about how we treat our equipment. We need to keep our software up to date. We need to not click on phishing messages.
Yeah, educate the population, right?
Yeah, so we really have a lot of work to do for many different organizations, institutions, and individuals to create a safer environment. But I am persuaded we will achieve that objective. I mean, if you think about it, we have road systems everywhere around the world, and we have automobiles and trucks and lorries and bicycles and motorcycles. And we found a way to make it safer for people to use that important transportation system. I think the internet will similarly discover a way forward because it's too useful not to achieve that objective.
And talking about the milestones of the internet, what could you point out about what was the biggest or the most impact milestones during these over the few decades ago?
Well, each individual will have different milestones that they remember. Yeah. The ones that I remember, I think, are, roughly speaking, the 1974 paper that Bob and I published in IEEE Transactions on Communications, which described what the internet was. The demonstration of a 3-network internet in November of 1977, which showed that the TCP/IP protocols really worked across 3 different kinds of packet switch nets with variable delay and variable error rates and variable speeds and variable packet sizes and so on. And it all worked. I was really, pleased to see that our TCP/IP protocols did what they were supposed to do. The 1983 official turning on of the internet, operational turning on of the internet. The 1986 or so introduction of the National Science Foundation Network Project, which meant that somebody other than the Defense Department cared about this technology, and followed very quickly by the Department of Energy and NASA in the US. And other parts of the world in the mid-1980s to the early 1990s, and the academic community was also building pieces of internet. The 1984 arrival of Cisco Systems, one of the first producers of equipment to let you build your own network using the Cisco Systems routers. There was another company called Proteon, which did not quite grow at the same pace. But the emergence of commercial equipment was important. Then in 1989, the commercialization of the internet in the US, 3 internet service providers, UUNet, PSINet, and SurfNet, simply heralded an important new milestone. Then in 1992, legislation in the US that said it was okay for commercial traffic to go on the government backbones. Then in around 1993, well, 91 was the release of the World Wide Web, but not too many people noticed until the Mosaic version in 1993 shows up from Mark Andreessen and Eric Bina. And that, of course, takes the world by storm in the form of Netscape Communications, which goes public in 1995. The stock goes through the roof, the dot boom is on, and the venture capital world is throwing billions of dollars at anything that looks like it has something to do with the internet. Then in April of 2000, the dot bust, when a lot of companies ran out of capital and wondered what happened. Then in 2007, the arrival of the iPhone and this sudden connection between the internet and the mobile technology world. And now that brings us up to, I would say, 2020, well, let's say 2019, and the arrival of the COVID-19 pandemic, which emphasized the utility of the internet for at least a significant fraction of the world's population who could work from home, for example. Although that's not true for everyone, and so there's a huge digital divide there. And now we see the United Nations pursuing its sustainable development goals and looking to 2030, hoping to get everyone up online if they want to. the arrival of the low Earth orbiting satellite system, in particular Starlink, but then there are others as well, heralding a time when it might be impossible to avoid access to the internet. So looking towards 2030, we will almost certainly have global availability of the internet. Whether it's affordable, I think we could argue, and that's a big problem. We need to push cost out, reduce cost, or supply subsidies. So that takes us to 2030. And then the last thing I would say in this compressed summary is that by that time, we will almost certainly have launched officially the interplanetary internet backbone. We're already well underway. We have our software running on the International Space Station. There's prototypes that have been running since 2004 on Mars. The Interplanetary Network Special Interest Group of the Internet Society is rapidly pursuing a formal effort to explore what an interplanetary backbone could look like technically, and also how it would be governed. Something that we didn't pay too much attention to in the early days of internet, but we realize now that governance is an important part of this kind of technology. So certainly by the 2030, I think we will see an interplanetary network in operation in preparation for the first manned landings on Mars.
And this interplanetary, would it benefit us in the Earth, or is just building over planet communication, connectivity? What will be the impacts, and for regular lives or interplanetary lives?
You could ask the same question of what's the impact of sending rovers to Mars, and the answer is knowledge. And the more we understand about how the universe works and where our planetary system came from, the more we understand about the world around us. So it's, this is basic science. But you've also seen in the last several weeks clear commercialization of near Earth space, and this with the suborbital launches and the orbital launch just recently of Independence 4. So I would say that although the general public may not experience space exploration in the near term, we can see the beginnings of space vacations in orbit around Earth, and maybe in the more distant future, we go spend some time at the Hilton Hotel on the moon. And of course we will see commercialization of space as well, which is a big issue, because figuring out how to govern commercial interests in space is still an unknown. It's a problem with an unknown solution. But we will have to solve that, because I am fully convinced that commercialization of space is quite real, and it will happen. It just may take some decades for it to blossom. But mining on the moon or mining asteroids is clearly increasingly feasible. Now, it turns out the protocols also have utility terrestrially, because if you're in a disrupted communication environment, the interplanetary protocols, the so-called bundle protocols, actually are more resilient over a wider range of parametric space than the TCP/IP protocols are. So they may turn out to be beneficial terrestrially as well as in deep space.
And what kind of the internet of the future, what kind of challenges this internet of the future will bring us, and what will be your advice to companies, to governments, to keep doing in order to have this multicultural, multi-stakeholder space?
Well, first of all, you want to implement IPv6, please, because it has a big address space.
Sure. I've been writing about it, I don't know how many years, and it's still a topic.
It's so frustrating to think that in 1996, I thought everyone would just do it because it was obvious why it would be useful. And
sure.
the deployment, had not yet reached the proportions that it has reached today. The trouble is, 1996 was literally at the beginning of the .boom period. And everybody was focused on building World Wide Web applications and expanding internet. And they said, we haven't used up the IPv4 address space, what's the hurry? So they just didn't pay any attention to that when they could have. And they focused on building businesses, which is not surprising. So here we are, 20 some odd years later. I'm hoping to see an increased attention to this deficit. The American Defense Department has announced that they want to have everybody running, at least capable of running IPv6 by 2025, and I hope they're successful at that. So that's one thing. The second thing is that the Internet of Things is clearly upon us. There are devices, an increasing number of them, that are programmable, have internet capability. Google makes those products, Amazon makes them. And the thing that we should worry about there is that there could be numbered in the billions, and attention needs to be paid to security and safety, because those devices can be abused if they aren't controlled. So as an example, the Dyn Corporation was knocked over by 500,000 webcams that launched a denial of service attack against the company a couple of years ago. And the fact that they could do that is attributed to the fact there was no security with those webcams. They either had no login passwords at all, or they had a well-known password that wasn't changeable. So paying attention even to small device security is important, and especially given proliferation. So that's the next thing we need to worry about, is continued attention to the safety and security of the things that are on the internet. We also need to pay attention to content on the network. I'm ignoring the harmful malware and ransomware for just a moment, although we really need to deal with that. But I'm also thinking about content that's useful and in languages that you speak, so that when you encounter the World Wide Web, you encounter things that are useful to you, and that requires some attention all around the world, since the continued dominant content on the net is still in English. So that's another thing to be concerned about. The last point I think I would make is that looking towards the future, we do have to solve the problem that Demi alluded to, which is governance of the net to make it safer, more secure, and an environment where people can be productive. So that's a big issue, and it's one that I know that Abranet and others will be working on, including me, as long as I'm able.
A question regarding Abranet. This is an association that brings together several kinds of companies from the internet value in Brazil. It's a very heterogeneous group of companies, from connectivity to content, e-commerce to telemedicine, distance e-learning, payment. Which is your view about the whole of the companies and entrepreneurship? I think this word is really difficult to say, in the develop on in the internet. I mean, what's the role of those entrepreneurs, companies, and making this environment?
Well, think about Abranet for a moment as a small model of the diversity of the internet. And you think of it as an example of a multi-stakeholder organization with many different perspectives. This is powerful because with those perspectives, you can speculate about what kinds of policies would work well and what kinds of policies would have negative components to them. So having groups like Abranet think about and express ideas about ways in which we can make the internet a safer place and a more productive place is really valuable. And having such a diverse collection of players in Abranet simply increases, at least in my view, the value of its views and opinions. And so I hope that it will continue to publish its views and share its ideas. So we need that kind of diversity in order to understand the potential of the internet in a wide range of different businesses. You mentioned distance learning and distance medicine, or remote medicine. And these are two things that we've been forced to learn because of the pandemic.
Yeah.
We've been forced to discover how hard it is to do a good job of distance learning. And we also learned that what we need to do for distance medicine, in particular, is to get devices that can sense your physical condition remotely, so that a consultation with a doctor who is not in the same room with you is still useful. And so you can see that's sort of one of the Internet of Things categories, which is remote sensing equipment for medical purposes. So you can just see the pressure that's been placed on all of us because of the pandemic, but it will produce a very interesting outcome in the end, which is to accelerate our ability to use the internet for education and medicine.
In About 10 years ago, the Wired magazine published a cover saying the web is dead, long life internet. 11 years passed and here 2021. In my opinion, web is, I don't know, it's really, really alive. And we still have, although we have a lot of applications and managing the internet in different ways. What do you think about that? And what you thought about, I don't know, 2010, back then when it was published?
Well, you know, of course, Wired magazine, like every other publication, needs to make, you know, bold assertions in order to get attention. This is the classic, you know, the famous expression about newspapers is, if it leads, it leads, and you know, so get people's attention. You know, the world is broken, we have to do something. In fact, I think what they were trying to say is that the conventional World Wide Web that was initially released was a relatively static thing. You could see all kinds of text, you could see imagery, eventually you got sound and video, but it was sort of formatted material. But then Web 2.0, if we can call it that, it's a marketing term, allowed for more interaction. And of course, as time goes on, people keep inventing new versions of the web for advertising purposes. Web 3.0 is sort of like 4G, 5G, and 6G. In some cases, it's no more important than the Skippy peanut butter label, which says, new Skippy peanut butter. And then at the bottom, you discover the only thing that's new is they stuck new on the label. It's still peanut butter. So I think what we are seeing, though, is a really interesting increased amount of software movement in the web environment. When you think about how browsers work, they download a file and then they interpret what's in the file. And what's in the file is not just formatting information anymore. Now it's executable code. So, you know, there's Java and there's JavaScript, and there are a variety of other potential interpretive languages that could be incorporated into the browser. So the browser becomes an operating system of its own. Eventually, this may lead to mobile software. I don't mean the telephone handheld mobile, but software that moves around in the net on its own to do things for you, which Bob Kahn and I worked on in the late 1980s. We called them knowledge robots. And we imagined that we would put software to work for us. Please go and out into the net, go find this stuff, put this together, and then let me know how that worked out later. And so the idea of programming a piece of software to go do things for you in the internet is not crazy at all. It's just that we're just reaching the point where the infrastructure, particularly the browser-based infrastructure, is there. Except now you won't need to have a person sitting in front of the screen. There's just a piece of software like a hotel waiting for the knowledge robot to show up, and the concierge is saying, hello, how can I help you? And the knowledge robot says, well, I need these resources for this amount of time, and here's my problem I'm trying to solve. And the concierge says, fine, no problem, here you go. And it does its thing. Doesn't this sound a little bit like cloud computing, where a piece of software shows up in the cloud and it runs its thing and it serves a bunch of people and then it shuts down? So you can imagine that the cloud computing environment becomes redistributed in the form of knowledge robot hotels.
We are coming to an end with this interview, and before we go, I'd like to ask you for an advice. What do you recommend to people, to the next generation of internet? I always remember a phrase that is print your photos. I never do, but I should. What else? What can you recommend to people for the next, I don't know, decades of the internet?
Well, related to print your photos, my big worry is preservation of digital content. And I'm worried that software will fail to run 100 years from now that you need in order to consume a digital object. And so I think we all need to say to the inventors of the world, please give some thought to the potential of a digital dark age. Please help us find tools to preserve digital content over really long periods of time. We know that books printed on parchment or printed on vellum have lasted over 1,000 years, but there are no media that I know of digital type that have lasted more than 10, 20 years. And so
Yes.
we really need to work hard either on new media or at least on a regime where we copy digital information into new media over time in order to keep it fresh. But we also need to preserve our ability to run old software and old operating systems in order to interact with old digital objects which have been kept around. So the preservation of digital content is the next really, really big, hard problem.
Thank you very, very much for taking the time to talk with us.
It's a real pleasure. I always enjoy having a chance to review the story of the internet and look towards the future. So I hope that your audience will find it interesting too.
I'm absolutely certain that they will do. So thank you very much.
Thanks so much. Bye-bye for now. See you on the net.
E para quem nos acompanha, o especial completo da Abranet, 25 anos, com uma série de entrevistas em vídeo, está no nosso hot site especial, abranet.org.br. Eu fico por aqui e até a próxima.